so in this video we're going to be talking about 1015, chapter 2.6.2, substitution method, solving systems of linear equations. Let's hop right into it. Now when we're talking about substitution, we're talking about two different equations. So let's just look at our first example actually. So we have this system of linear equations. X equals negative 4y minus 3, and 4x plus 4y equals negative 72. And in this example, the thing that we're going to do is we're going to say, okay, we have an x equals something, or a y equals something. In this case, it's x equals something, negative 4y minus 3. And one thing that is a little unintuitive at first, but makes sense, is that this is what x is. X is equal to negative 4y minus 3. And because we know that x is equal to negative 4y minus 3, we can go to our second equation and say, okay, I know what x is. I'm going to plug in negative 4y minus 3 for our x. And then we'll have plus 4y equals negative 72. And this is actually a great thing for us because now we only have y's. And so we can solve for what y equals. So let's do that. We have 4 times negative 4y, which is negative 16y, minus 12, plus 4y equals negative 72. I'm going to add 12 to both sides to get a y by ourselves. So plus 12, that will give us negative 16y plus 4y equals negative 60. And then I'm going to combine these two, so we have negative 12y equals negative 60. I'm going to divide both sides by negative 12. And so we get y is equal to positive 5, because 5 times 12 is 60. So now we know what y equals. We have y is equal to positive 5, right? But we don't know, we want a number value for x. Because even though this is what x is, we still want to be able to say what our number value is. So we're going to take our first equation and we're going to plug 5 in for y. So we have x is equal to negative 4 times 5 minus 3. Now, one thing to note is it's best to go to the equation that you didn't solve to plug in your new stuff. You want to go to the opposite one, the one that you haven't worked with yet. So, because you just want to make sure it works for both equations. So we have x is equal to negative 4 times 5, which is negative 20, and then minus 3, which is negative 23. And so our answer, and they want it in a coordinate pair, is going to be negative 23, comma 5. And we can test this out. We can say, okay, negative 23 is equal to negative 4 times 5 minus 3, and that will give us negative 23. And we can say negative 4 times negative 23 plus 4 times 5 is equal to negative 72. And let me do that math really quick. Okay, so that actually, it's really good to check your answer because I realized that I did something wrong with that. Give me just a moment to recheck my answer, figure out what it is. Never mind. I realized that when I was multiplying, I did negative 4 times negative 23 when it should just be positive 4 times negative 23. And that makes our answer correct. So it's good to check again and then see if you did anything wrong. I actually had done it correctly. I just, in the end when I was checking, I made a mistake. Now, this one's telling us to solve the system of linear equations using the substitution method. Input your answer as an ordered pair. I'll just go through a few more examples of this to make sure that you have it, and then there'll be some examples that have some interesting aspects to it near the end. So this one, it already has done it nice for us, putting the x by itself. So we have 6 times negative 2y plus 2, because this is what x equals, minus 3y equals 42. That will give me negative 12y plus 12 minus 3y equals 42. Well, minus 12 from both sides. And then we'll combine these two. So negative 12 minus 3y is going to give us negative 15y. And then equals 30. And then we'll divide both sides by negative 15 to get y by itself. And that gives us y is equal to negative 2. Now we can go to our beginning and do x is equal to negative 2 times negative 2 plus 2. So that gives us x equals 4 plus 2, which is 6. So x equals 6. Then we'll check with the bottom one. So we have 6 times 6 minus 3 times negative 2 equals 42. That's 36 plus 6. That gives us 42. So that looks like it's our solution. Our answer will be 6 comma negative 2. Don't forget your parentheses. This one, we have it what y equals, so we'll keep our x. So negative 5x minus 4 times 3x plus 12 is equal to negative 48. That will give us negative 5x minus 12x plus, minus 48 equals negative 48. And this was supposed to be minus. Hold on. I think, yes. So now we have negative 5 minus 12, which is going to give us negative 17x. And then we'll add 48 to both sides. And that will give us equals 0. And so we'll divide both sides by negative 17, and that will give us x equals 0. Now we'll plug that back into the beginning. We'll get y is equal to 0 plus 12. So y is equal to 12. And let's plug that in. We have negative 4 times 12. Yeah, okay, so our solution, is going to be 0, comma 12. This one's asking us to solve the system of linear equations using the substitution method. This time we need to make it so we need to alter the equation a little bit so we can have it work with the substitution method. So we'll move the 2x over. We'll add 2x to both sides. So we have 2y is equal to 2x minus 2. We'll divide 2 from both sides. That gives us y is equal to x minus 1. And so now we'll plug that in. We'll have 8x minus 8 times x minus 1 equals 8. That would give us 8x minus 8x, minus 8 equals 8. Sorry, that should be plus 8 because it's a negative times a negative. Then we'll minus 8 from both sides. And this will turn into 0 equals 0. Now, when you get a 0 equals 0, that's really interesting. That means that there's infinite many solutions. And so we'll circle that in, infinite number of solutions. And that means it leads to an identity. And what that is, basically, is we want to write the equation of the line that, because if you remember, an infinite number of solutions means that it's the same line, right, on top of each other. So we want to write what that line is. And it's simple as this. Y equals x minus 1. That's our general solution. This next one's sort of similar. We'll move things over. So we have 2y equals negative 3x minus 1. Divide both sides by 2. Y equals negative 3 halves x minus 1 half. And then we'll plug it in. So we have 9x plus 6 times negative 3 halves. X minus 1 half equals negative 3. 9x plus, so this will turn into 3 times 3, 9x, and it'll be minus 9x instead. And then minus 3 equals negative 3. We'll add 3 to both sides. This will turn into 0 equals 0 again. So we still have an infinite number of solutions. And our line is going to be whatever we found like with this. So it'll be y is equal to negative 3 halves x minus 1 half. So that ending part is a little interesting. Just because we had to think about what the line on which the solutions are found on. So yeah, if you have any questions, please let me know and I'll answer it as soon as possible. Have a good one.